now we are in the water use tab, and just to back up a little bit, Dee and I are actually using a workbook that's already populated with some information, just because that's a little easier to see it with data in it. But I wanted to talk about each of these analysis tabs, and the energy analysis tabs are going to be all similarly laid out. And you can see the list of all the tabs across the bottom, and now we're in the water use tab. The layout of each of these tabs, and I'm going to make this really small for a minute just to show you, but at the top of every worksheet is something called the recommendations. In this case, this is the water efficiency recommendations. There's going to be a chart that essentially any of the recommendations that are generated on water will flow up to the top of this page to this chart in the very end, and then this is the information that moves on to the in a summary form to the water assessment report in the end. So and all of our analysis tabs are all set up this way, so you're all going, the first thing you're going to see is this chart. And so Dee said, you know, in the light blue there's some instructions and maybe how to go through this. I mean, in general, I just want to let you know that the layout of our reports are kind of an 8.5 by 11 portrait size. So everything on the left is really going to be kind of what's in view, or might move over to the report. And we've tried to keep the width of that within that 8.5 by 11 space. Everything to the right might be guidance or extra information. So again, because there's, you know, there's a lot of information and things that might make this thing look busy. But I'm just going to scroll through and talk about some of the pieces in this first, and then we'll go back and look at it a little bit more detailed. So we're at the very top left of the page. We're in the water use tab. Here's our assessment table. I'm going to blow that. Oops, I'm going to blow that up a little bit so you can see it. And again, you know, this is kind of the executive summary piece that will come out in the end. As we go through here, this begins with, we've set it up that you can begin with information about the water use history. And most of these sections are set up where you have this yellow input screen where you can type in your text to describe or to communicate that history, and it may be paired with a graph or a chart or a table. So in this case, we have the water history tab comes in there very nice, and we may want to talk about that and type in here in our narrative. We could explain, you know, what the total water use is, why the trends are the way they are, and any other information that we'd like to share. So most of the pieces of information are kind of set up this way. Let me show you what, in this case, what this might look like in a completed workbook. And now we have some data in it. In general, this workbook is set up that there's lots of rows and lines for anything that may be said. And so a lot of times there's going to be lots of blanks that carry on through the whole workbook. But in the end, when we do our report, all those blanks will go away. So again, in this workbook I just want to say too that this workbook is just for us to use. So the client will never see this workbook. So it's really just a tool for us to develop those pieces. We can do with it what what we want, and what will be key is when we finally output the report or generate the report in a PDF format is the only thing that the client will ever see. I don't think we really have ever shared this workbook with the client. So here we're back in that same place now with an actual example, and we have water usage and water sewer cost. And so here's our graph, and you can see that this assessor typed in some information about when the use was, about what the water rates were, what the average cost per gallon was, and those kinds of things. So that's all typed in here in that yellow section. Oops. A little bit bigger. So there we go. And then the chart accompanies that. Okay, so let's keep going down through this water assessment tab just to show you all the pieces that are in it. One of the key aspects of when we do a water analysis is really kind of creating a water balance and analyzing where all the water uses are in a facility. And so this current and future water use by category, this is a big chart that helps you do that. Um, and I'm not going to say a lot about all the detail in this because they're probably spend a lot of time talking about how we generate this information. But so in this current water balance, it allows spaces for the common domestic fixtures that you see, lavatory, restroom kinds of faucets, um, shower heads, toilets, um, and you can you can fill this chart out and it will automatically do your calculations for you. Much of the water balance work is really based not on square footage, but really on the number of users. So in this case, we were estimating what our water use was from the domestic faucets, and we knew that we had 350 users as an example. They were they were washing their hands 3 times a day at 15 seconds. This is in minutes, so it's 0.25 minutes. The flow rate in gallons per minute was a half a gallon flow rate, so they already had a very efficient commercial hand washing faucet. Um, and this generated, okay, there's the use per day, 131 gallons per day. You can put in here on the yellow that, okay, the grays are calculated. And then we were saying that there was 250 days per year in this particular educational environment, and it generates 32,813 gallons of use per year. Um, so these two charts to get to current use, a lot of those calculations are already built in, and you can do the same if you had shower heads, if you had toilets, um, and you can work through your your use data. Um, this chart, because it's all consolidated in one place, we went ahead and put future water use where you could also project what the new reduction in water use would be for any water efficiency recommendations. And so, for instance, in this case, with those laboratory faucets, we're not going to recommend anything lower than a half a gallon, so it's the same number in there. But this kind of uses kind of the current state and future state like a leaning manufacturing exercise. That's kind of the vocabulary we're using here. Um, so let's look at an example of a toilet where we actually do have a recommendation. In this case, as we were breaking users into kind of male and female users because we had some toilets paired with urinals, and then we just had some toilets for the female restrooms. And so in this case, we had 175 users. This may be one of the female restrooms. The gallons per flush GPF was 2.5 in this case because they had adjusted the flush valves to be wide open. And this calculates up a gallons per day. We know how many days per year, and it calculates up a gallons per year. Our recommendation is to reset those back to a code compliant 1.6 gallons per flush, and then this actually calculates up the new water use, not the water savings, but the new water use. So that's an example of a toilet calculation. The top part of this chart handles all those common domestic fixtures with kind of subtotals. And then the bottom part handles other kinds of water using equipment that we see primarily in commercial applications. So this includes things like kitchens and dishwashers, clothes washers, laundry, cooling towers on HVAC. In this case, we had laboratory sinks in this science building, and there were 54 of those. And we made some estimations of what the water use per day was because it was a real high flow rate, like 6.5 gallon per minute faucet. And we did those calculations. Now, in some cases, you may have to, put in your own calculations and calculate this and put this in, because within a prescriptive worksheet, we can't really handle every scenario. But you can do that. And there's a column over here that allows for some notes on if you need that. There's some pieces here for irrigation, pools, and other. This isn't going to handle everything on an industrial. There's not as many places for kind of industrial process equipment, but uh, it allows some flexibility to encompass all of the uses in one place. And if we're making a recommendation to predict what the new use would be. And if we go down here a little bit further, the data from that table comes in here and populates this chart for current use and future use, and actually creates a little water balance chart, visual chart, which will then be used in the final report. So that's generated. Um, and then we can, as we keep going down, there's another kind of way that we can present the data, which I kind of like. This kind of shows current and future annual consumption based on our recommendations. And in this case, we had a lot of recommendations for on the HVAC side, and the process equipment was actually, in this case, was really the laboratory sinks. But you can see kind of the before and after, and some savings in the toilets. And so this graph too is populated in a way that it's going to show most of the major recommendations. But as you get better at this, you can actually modify this so that you can choose just what you want to show. And in this case, you can choose these chart filters. And if you scroll down, you can actually take out some of the things that aren't being shown, like laundry and kitchen, and irrigation and other. And then we can apply that, and we have a little bit of a cleaner chart. So those are some things you can kind of learn over time. And then this very chart will be the one that goes into your final report. But there's just, and you may not choose to even show your data in this format, but it gives you a lot of options. As we scroll down, there's more detailed summary of recommendations here, where now beyond just knowing what the water savings are, we're actually including information about the upgrade costs and the payback. And so this one is again completed for some of the recommendations that were in the science buildings, which included the toilet readjustments for both the male and female restrooms. We estimated these were actually a flush valve adjustment, no equipment cost, and we put some labor at $10 per unit, and this calculated a payback. This particular building had a major cooling tower management issue, where a lot of the cooling tower water was really almost going through in a once through fashion, and there weren't controls to recirculate that, and a conductivity controller to monitor and reduce the inflow of that. And because of that, there's a big 22% savings opportunity with really just utilizing equipment that was there, and getting maybe a vendor on site to help them do that. So this kind of summarizes up the information and again in a chart format. Again, there's lots of blank spaces, but in the end, when we show this in the final report, those blanks all go away. But while you're working on it, you're going to see all those blank spaces as well. I'll also say here that I know that George and Barry worked hard to capture the cost savings due to hot water that might be used in some of these applications. And in this case, everything we were using even was really cold water, so there's not any energy savings calculations in this particular example. But in here, you can click on a drop-down menu and choose whether the water heating might be natural gas or electric. And there's some places for you to, it would actually bring in the cost per kilowatt hour or the cost per therm that would come back from that utility tab. and that would be populated here, and that would be built into your cost savings calculations for any hot water that's being used for these water savings parameters. So suppose we were saving um, shower head water, well, then that we would be calculating a BTU savings at the average cost per energy that's being used to heat that water, and then that would be built into this table. So that's kind of a nice thing that you don't have to do, but we can capture those cost savings in this table. Um, so we've just talked about how we can kind of do our water balance. I'm going to scroll back up to this big chart where we can put in all of our uses and kind of quantify what we think people are using. And it gives us an opportunity to go to the future state, and then that generates a water balance. And then we can go into a little bit more detailed chart that includes kind of the upgrade cost and payback. Um, so I said I didn't really want to talk about like how you come up with these values and what you should be using, but I do want to say that um, the workbook is somewhat of a repository for some guidance information. And in this case, since like the choice of domestic fixtures is fairly straightforward, if you scroll way down in here in this chart, um, there's some application guidance. And in this case, I just want to show you there's a chart that we've used for several years that we keep updating. But like in this case, it it gives some guidance on the kinds of fixtures you may find out there, the age of those typical fixtures, and what you could upgrade to, and some estimated costs. You know, a lot of that stuff is a moving target. There's a lot of cost factors that influence on bulk purchasing and so forth. But I just want to let you know that there is some application guidance, like at the bottom of this particular worksheet too, that could help you. Um, because you may say, well, how do I know how many flushes per day, a hotel would use? There may be some guidance here on typical use consumptions that gives you a starting point, and this can vary quite a bit. I don't, it's nothing is etched in stone, but it's a starting guidance for you. So without going into that level of detail of all the technical considerations, I just want to let you know that some of that is here and available for you to access right on the worksheet. Questions or input here?
Yeah, Terry Conrad, just trying to understand, because as you were going through it, I got a little bit lost.
Sure.
Is when we have a client and we're trying to figure out water usage, and I'll just use the toilets and urinals as kind of like the prime example. How is that split happening again? Are we inputting that, or is there a base assumption of 50-50 or something like that? Can you maybe cover how that happens again?
So it's not happening automatically for you. So all these yellow yellow spaces are things we're inputting. So on the toilets, I'm going to call this particular entry the male toilets or the male restrooms. Okay. So I've got 175 users, one use per day. And then down here, I have the urinals, which kind of pair with that male toilet use. And I'm saying that in this case, they're going to use that urinal 3 times per day. Now, is that number right? Should it be 2 or 4? Or, those are numbers that do have some flexibility. When we do the water balance, sometimes we see if all the water assumptions we made add up and see if we can kind of justify where all the water use is going based on our assumption. So that's one way to know if these values are correct. I mean, I would tell you that if I'm estimating this in an assisted living facility, those uses per day might be double that. So so there's a lot of variation, but that's how that is broken out. A lot of times I even hate to break out male, female. I like to just group it all together. But when we do have urinals involved, you kind of have to break it out because in this case, it's kind of interesting. They have a 1 point flush urinal in this case. So they had upgraded their urinals to like the lowest imaginable, except for waterless. And that's not a lot of water use, per 16,000 gallons per day based on, versus the toilets using 300 400,000 or 420,000 as a total. So those kinds of assumptions do make a big difference, especially when there's water efficient fixtures or they have all those choices. So does that
So
help?
yeah, it does. I mean, I see it now. As soon as you typed in female and male on the toilet side, I figured it out. But um, should did we ask in the all the way back to the pre-assessment form the split between male and female, or will we do that when we go on the assessment?
Yeah, it's not asked up front in that pre-assessment form, so that may be something you need to ask during the assessment, if it's even an issue. I mean, in some small commercial facilities, it may not even be an issue that you have to break it out,
Yeah,
but you may have to.
yeah, agreed. It's just that you have to remember to ask that question
Hmm.
if you get into a larger facility and notice urinals. You know, we'll
Hmm.
just have to remember to ask.
And honestly, I think in this example, when this was done, I think I'm not quite sure, it was kind of 50-50. 75 and 75 don't add up to 350 users. So I think there might even been some additional numbers added in for extra, users that were not quantified in that 350. So, I mean, there's a lot of flexibility, but it is a thing to note, especially if, um, you're not near a 50-50 split. On the right-hand side of this page, Dee was mentioning there's a lot of, um, kind of hints and guidance on how to create the water balance and some things to step by step walk you through. I'm not going to spend, you can read that as guidance as you get stuck. Because I know I'm showing, these are long worksheets and there's lots of pieces and you're going to have to look at this a few times before you know where you are and become familiar. I do want to point out a little new feature we added. Um, we've been doing a lot of work where there was significant cooling tower loads on some of the institutional facilities we were working on. So we created this little, cooling tower, assumption estimates that you can put in, the tonnage of a cooling tower system and its blowdown concentration ratio, and it will generate a theoretical water use. So, in this case, and I can change these numbers, if we had water that was almost running through this at, um, one point, let's say, at a blowdown concentration of 2, which is really low, you use 2.8 million gallons a year. And then if we can go to something which is more rational, like 6 or 8, this is the number of times the water is used, or let me say it's a ratio of the cleanliness of the water before it's discharged. So you can kind of use the water till it's 6 times as dirty before you discharge it. In that case, you only use 1.7 gallons. So there's significant opportunities to reduce water usage by changing that concentration ratio, which is something that most facilities that have a cooling tower management system, they can do that. And there's pros and cons with doing that, and you can't maybe run a tower too dirty. There's issues there, but it's something to revisit. In this case, they were almost not even using the recirculation component of their system, so there was a lot of opportunity here. Um, but in any event, there's some information there that's rather new, and it's a little sophisticated how those numbers are estimated, but it's at least one estimate that you could use if you needed to. Okay, so we got down to a chart where we were estimating the actual payback periods. After this point, we wanted to give the assessors the ability to describe some of those recommendations in more detail. So this next point at, this line 240 says discussion of water efficiency recommendations. And here we have a chart and we have a yellow input screen. And so these charts kind of break out line item by line item what some of the common recommendations are. and allow the assessor to write a description of what that might mean for this facility. Many of these, again, they're all shown and then they'll go away in the end. But let's go down to one where we actually have it filled out. So here on toilets, we have what the upgrade option is and the water savings and all the way to payback, cost and payback, and allows you to type in something that describes what was going on. And in this case, what we found was we found these flushometer valves were adjusted to be kind of maximized, and they needed to be reset to be in their normal operating mode of 1.6 gallons. And we can describe that and talk about how that might happen, or, you know, this may be a high efficiency toilet. We could describe what that is or how to choose the best one. It just allows you a place to write what you'd like to write about. Let's go down a little further here. So this is the lab flow restriction nozzles. These charts will automatically populate because these are all gray areas, so that all this data comes in from above and allows you to write. In this case, we're saying, hey, the lab nozzles were measured at 6.5 gallons per minute. Water conserving lab flow restrictors can be cost effectively and easily installed. 2.0 gallons per minute are used for the calculation purposes, but lab nozzles can be specified with flow rates as low as 0.4 gallons per minute, depending on the lab use and needs. So, so that just allows us to talk about maybe a more reasonable flow rate depending on what those labs are doing. So that's just an example on how you might actually qualify. So this is kind of near the end of the assessment. When we roll this up into the report, this piece will be near the end, but it lets you describe that recommendation in additional detail. And we have a similar discussion on the cooling tower optimization that talks about what we thought was going on with their cooling tower use here. Okay. So once all these individual breakouts of the recommendations are made, and they are all summarized again in this last chart, which is right here, these values then go back up to the very top of our chart in this summary, which allows us to have somewhat of an executive summary. And you can write just, you know, a few word description of what that is here in yellow, and then you have the water saved, the cost savings. These are kind of the basic things we're tracking in the executive summary, including a BTU saved if there's an energy component to that. These charts over here on electric, kWh, and therms, these are where you might have hot water usage, and this is just kind of extra information so that we know what those BTUs were. If it was an electric hot water heater, it's going to show up as kilowatt hours, but in this case there wasn't any hot water, so all those are blank. But so this rolls up into that section. And so in this case we just had 4 major recommendations for this review, which in the individual building, this was, I don't know, 100,000 square foot educational building, you know, that's probably about the number of quantifiable recommendations that you might have. And then this would then information would then flow over into the assessment report.